Now let's consider the behavior of graphs of functions. Example 3. For the graph shown, number 1, determine the intervals on which the function appears to be increasing. Reading the graph from left to right, we can see that the curve starts out at a pretty high point and then it decreases since it's dropping. It reaches the value 1 comma negative 1 and it starts to peak up. So the portion that's highlighted is considered to be the part that's decreasing. Then it increases from this point on up to the value 3 on the x-axis, and then it decreases again to the value 4, and then it increases from 4 on. So the portion that's highlighted in yellow is considered to be the decreasing part, and the portion that's highlighted in blue, it's considered to be the increasing part. So to answer part 1 of the problem, the interval on which the function appears to be increasing, that would be from negative infinity to 1. We only look at the x coordinates when we determine intervals, and then from 3 to 4. Since these two subsets are disjointed, we're going to combine them with the union symbol. For number 2, identify the intervals on which the function is decreasing. That's the portion that's highlighted in blue. So that's from 1 to 3. Again, reading the values on the x-axis only. And then from 4 to infinity. On number 3, determine the coordinates of any local maximum point. So a local maximum would be this point right here. We look for a mountain, hence 3 comma 1 is the local max. And now to determine the local minimum points, we need to look at all the valleys. So here we have 1, and here's another one. Once again, a local minimum is a value of y for which it is the smallest y value of its nearby neighborhood. So we consider the open interval around that point. We can see that this y value is the smallest compared to the surrounding y values in its near neighborhood. Hence, that's a local min, which is at 1 comma negative 1. And here's another, which is at 4 comma roughly 1/2. So to answer question number 4, these are the local minimum. Moving on to example number 4, for the graph shown, find all absolute maxima and minima. So an absolute maximum is basically the largest y value where the graph is defined over its entire domain. Over its entire domain, we have two highest points, and those are at -2, followed by 16, and +2, followed by 16. So the absolute maximum is 16. For the absolute minimum, we need to consider the smallest y value over its entire domain. So the smallest y value would be halfway in between -8 and -12. So that would be -10. So we can say that the absolute minimum is the function value of -10, and the absolute maximum is the function value of 16.